Alright, so I wanted to go over some other odds and ends from Bash, things that we haven't talked about, but are related to things we've done or things you might want to do in your own scripts. And a lot of these have to do with reading from something other than user input inside a Bash script. So let's make just a script. I'll just call it A. And we know we can say, read name, and then echo what the person's name is that they typed in. And if I run this, it's not prompting me, it's just waiting for a name. I can say A, B, C, D, E, and it says name equals A, B, C, D, E. So we know how to do that. But suppose we want to do this in a loop. We need a way for the user to exit the loop. And, we can say something like enter a blank line when you're done. But the usual way to do this is to signify end of file, which we do by hitting Control D. And this is useful if, for example, we're reading from standard in. When we get to the end of the file, then if we're redirecting a file to standard in, when we get to the end of the file, it will generate an end of file signal. And we need a way to pick that up. So here's how we can make a while loop that reads from the user until the user hits Control D. We can say while read name do, and then say done. And we'll put a message down here that just says end of file detected. And so if we run this, I can, type A, B, C, D, E, and I can say Nick. And I can say hello, and I say gonna hit Control D, and now I hit Control D in the beginning of a line, and it says end of file detected. And when you do this, it's important that we don't hit Control D anywhere except the beginning. So I just hit Control D at the end of the line here, and it says name equals hello, and it's continuing to ask me for my name. But at the beginning of the line, if I hit Control D, it'll say end of file detected. So now if I say A less than test file, remember test file is my little file that I created in the dialogue video. If I say A less than test file, it reads each line of that, says name equals, that line, and then end of file detected. Or if I were to say something like df, which displays my file system information, I can say df and pipe that into my script. And now it reads each line of the output of the df command, takes that as an input, and at the end of df's output, when df exits, it says end of file detected. So this is a useful way to read in a loop and have a standard way of getting out of the loop by hitting Control D or hitting end of file just while read name. So that's useful. But sometimes we want to read the output of a command inside a script. We don't want to read from standard in and pipe a command's output into our script. We just want to read directly from a command. And so I might say while read name do, and I can print out the name. But on my done statement, I'm going to do the following. I'm going to say less than $, and the name of my command that I want to execute. And this structure here says, okay, run the df command and take that as what's being supplied each time that we see a read statement. And the while read says when we detect end of file, which means when the df command exits, kick yourself out of the for loop. The while loop. So now if I run this, right, it executed the df command inside the script, printed out each line, and then told me it was done. So I can change that to say next line is, and now it shows me each line of my df command. So that's a good way to run a command and capture the output one line at a time, as opposed to if I just did something like this, output equals $paren df, Well, if I do that, I get one big long line with everything all strung together side by side. That's a lot harder to parse meaningfully. Like this, I go through my loop, and each iteration of my loop, this variable name in this case, is set to the next line of output from this command. So that's a good way to break things apart. Alright, another option we have is specifying the contents of stdin inside a file. So in this file, for example, I'm running the command cat, but instead of redirecting stdin from a file with less than, I'm using two less than signs, and I'm putting down just an arbitrary string here. And somewhere else in my script, I'm going to repeat that string. And the deal is, everything between here and here is being sent to stdin of the cat command. So cat, as you may know, reads stdin and copies to stdout. So this script will take everything I've got highlighted here and basically display it on stdout. And then it'll say that it's done. So if I run that, right, it's displayed all of those pieces of information. And this is, a useful way to generate a bunch of output without having to say echo in front of every single line. Or, if I wanted to do some calculations, I could do something like this. Right, and say, hey, let's do 2 plus 3 plus 4, 12 times 79, 5 raised to the 21st. And when I run this, I get the output of those calculations. So that's a useful way if you want to run a command and specify certain things for stdin. Instead of creating an external file, we can put the contents of what we want to go into stdin right inside our script. So that's potentially useful. All right, some other useful things to know. There's a shell variable named random, and it's equal to a random value. And each time that we look at this variable, we get a usually different value. And it's a 15-bit number, so it's from 0 to 32767. And we can use that to, generate other random numbers. Another good command to know is xxd. xxd is a way to get a dump of a file that might not be printable. So if I say xxd test file, right, I can read my file 16 characters at a time over here on the right. Except, there's some dots here and there. Over here on the left, I can read the hex value of each byte of my file. So that's ASCII code T, this is ASCII code lowercase h, is, 20 is a space, 69 is a lowercase a, or lowercase I as, 20 is a space, 61 is a, and so on. This dot over here could be either a period or a non-printable character. Let's look at this dot at the very end here. Well, that's ASCII character 0A. ASCII code 10 decimal, that's a line feed. That's what we put at the end of lines inside Unix files. So if we have a C program, so there's a simple program that doesn't do anything. And I try to VI that executable file, I see lots of strange stuff. And if I were to cat this, it might cause weird behaviors in my terminal. It might change my background color and things like that. But if I XXD this, I get a nice clean output. It's not going to generate any escape codes or anything that's going to potentially disturb my display. And if I pipe this into more, I can look at it one page at a time. And executable files on Linux, they always start with this tag 7F454C46 ELF. And then, there's lots of ASCII code zeros, there's an ASCII code 18.3, and so on. And there may be some printable text in here, like here's a path, lib64 LD Linux, and there's the ASCII codes. But then these are all, non-printable characters. But I can look at them in terms of their code in hex and see exactly what their values are. So XXD is a useful command for examining files, especially if something strange is going on and we're not quite sure what the meaning of it is. One other useful tidbit. We have a script, like our A script, which was running the BC command and doing some calculations and so on. And let's say we have some more interesting things going on in here, like x equals 12, y equals x plus 2, for whatever reason, right? So we run this and we see the results sent to standard out. So we can also run this explicitly by saying bash followed by the name of the script, and that's not very different. But if we do that, we can put a switch -x, and when we do that, we get a little more information as the script is executing. In other words, here it's showing us x equals 12, y equals 14. Now it's running BC, and it's generating this output, and now it's going to run the command echo done, and there's the result of echo. So this bash-x switch can help us track a program as it's executing, and sometimes that can be useful for identifying where there's problems going on inside a script. All right. One final option with respect to looping through a set of input. So sometimes we generate a set of input and it appears all on one line. So for example, if I say ls, I have a whole bunch of files sitting in this directory. If I say something like files equals $paren ls, and then I echo $files, right, I have just a big long variable containing a whole bunch of words separated by spaces. And there's a mechanism we can use in bash to iterate through a set of space separated words. And the mechanism is a for in loop. So I can do something like this: for file name in, and I'll say $ls, do echo next file is, and I'll just output the value of file name. So I'm writing a script here on the command line, and then I'll say done. And what this is going to do is execute the ls command and then go through this resulting output one word at a time. And by default, words are separated by spaces, so it's going to set file name equal to 215 and say, next file name is, and it'll say 215. And then the done will take it back up to the top of this for loop, which will look at the next word in this output from ls, 222, and it'll say next file is 222, and so on. And so here's, going through the results of the ls command one line at a time by basically breaking this out into words. And that can be really useful for breaking up information and processing it in a controlled way.